what we're doing today is we're looking at proportional and integral once again. Okay, I know that we've already looked a little bit at integral over the past two classes, but today we're going to finalize integral. Okay, what we have to understand first and foremost is what integral is and how it differs from integral on a controller. Okay, as we've already looked at, the integral is a calculation to determine the area of a lot of times of a parabola or a circle or some other object. So the one thing that we have to understand is there's two different ways of doing these calculations. One is through Riemann, he goes based off of going up and down to find the area below that line. And I don't know this guy's name, Lebesgue, and he goes horizontally. Now, when we get in, if you want to get into all these calculations, it could be quite complicated. And it is complicated. And not only is there calculations that go that just go up and down, but then you can get into three-dimensional, and even instead of just coming up and saying from here to here, it's just horizontal, you can actually do a triangle and find that area as well. But the one thing that we have to understand is how our controller works. A PNID controller isn't calculating using these fancy equations. It is literally sampling at one specific point. But it samples very quickly, right? So basically the calculations that we have done and that we are about to do are the same calculations that your controller does, except it does them once every hundredth of a second. Okay? And that's why the controller, it seems like if we wanted to calculate it out, we would use integral calculations like this. But to make it simple, the way that we have been doing it, and the way that we are going to continue doing it for now, is we are simply doing, wow, that's needs to be a little bigger. Like a little more like that. So, proportional gain times your error plus proportional gain over your interval setting times your error times your time in minutes. Now, we've had no issue with this. This has been very easy and very straightforward. However, the one thing that we have left off that we are now going to put on, which is one of the final pieces of the puzzle, is the fact that we are in reverse mode. Okay? We're not in direct acting, we're in reverse acting. So the way that we have been doing our calculations, because we've always been on one side of the set point anyways, I left it unitless for a reason, to make it easier on you. Okay? So now we're going to actually add the positive or negative sides of the equation. Okay? So when we have reverse acting, we're always going to have times minus 1 times minus 1. And that puts all of our outputs reverse acting. Okay? Keep in mind we haven't got the derivative yet. So now whatever the error is, our output is going to be the opposite, okay? When we have a set point of 50 and we have a process variable at 45, the way that we have done it was without having that -1, our output actually would have been below the set point. But now with the -1, our output is actually going to be above the set point because that is reverse acting. That is the way that our controller is acting. We gotta remember that reverse acting and direct acting have to do with what our process is going to do. In reverse acting, if the tank level is starting to go low, then we want to start increasing our variable frequency drive pump in order to get the process to come back up to the set point. Okay? Now, if it was direct acting and we had a valve that we controlled that was allowing the water to come into the tank, we would want direct acting, in which case when the a valve on the output. If we had a valve on the output of a tank, so that was with a VFD, you want reverse acting. But if you had a valve on the output of the tank, and all of a sudden your set point was 50% and your process started to fall below that set point, you would want your valve to close. So on a direct acting system, as the process variable drops, your output would also drop, which would then close your valve, which would then increase the level of the tank. That makes sense. So now what we're going to do is we're going to run through some calculations with the formula in this scenario. Now I already went ahead and did out the calculations, so I didn't have any problems here. What we want to do, now in our lab that we're going to be doing, all these steps are not laid out in the lab because you have to do all these steps in order to understand before you get to the lab. Now what we're going to do is we're going to do out the steps in the proper way. So when we have a graph and we put our set point, let's say our set point's at 50%. And we are going to start our valve at 0. Okay? We are going to start at time equals 0. And then we are going to go in half-a-minute intervals, 1.5, 2, 2.5, and then we're going to jump 2 minutes at the end. Now, in order to calculate our first value, we're going to go proportional gain times our error times 1. Now, the one thing that I didn't do was actually write down what I did write it down right here.
Sorry, the numbers at the bottom are seconds?
Those are minutes. We're always dealing in minutes, right? So, we're going to set this with a proportional gain of 1. We're going to have an integral of 0.5. We are going to have we have our time and our error. Now, keep this in mind. If a person says that your process variable is at, so process variable is at 5. Our error would be what? What? Yes, it would be 45. But because we did this without plus or minus last lab, now we have to get on track with the positive or negative sides. Okay? So it's going to be, from our set point, it's going to be an error of negative 45. So when we do this, we go proportional gain, which is 1, times our error of negative 45 times negative 1. Okay?
So when I put error in a formula, it will be set first variable minus set one, right?
Pardon?
So when I put error in a formula to determine if it's minus or negative or positive, it will be first variable minus set one. That will be minus 45.
Yes, you can do that if you want. You can, that's just adding steps. You just have to know that your error is your set point minus your process, or your process variable, your set point minus your process variable, and it's the deviation between the two. If it is below, if your set point is above your process variable, it's going to be negative. Okay? Now, just bear with me, and you're going to see it here, okay? So we have a proportional gain of 1 times our error of negative 45 times our reverse acting, which is minus 1. Reverse acting is minus 1, okay? This was not from before, okay, because we did not do this before, okay?
So your PG says -1 on top of that.
No, sorry, that's like process gain equals 1. Integral equals 0.5. Okay, so 1 proportional gain times our error of minus 45 times negative 1. Okay? So now, we're going to add our proportional. Now this is at time 0 right here. So our proportional gain of 1, integral of 0.5, times the error of minus 45, times the time of 0 times negative 1. Because that's 0, everything is 0 there. Okay, everything there is 0 because when you times 0 by 0, it's 0. It doesn't matter if it's plus or negative, positive or negative. But for a proportional side of it, it is going to be 1 times minus 45 times minus 1, which is going to be 45. So our output, our V out or our valve out, is going to be 45. Now I'm going to actually put that in red. 45. Okay? And our process variable, it can still be in black. So we've done this before with the exception of the minus. Okay? So now what we're going to do is, we're just going to move this up a bit, and we're going to do the same thing, except we're going to do it at 0.499 seconds, okay? Right before it crosses over to 0.5, because at, sorry, I said seconds, 0.5 minutes. At 0.5 minutes, we should actually draw our process variable. Our process variable is going to remain at 5%, and it's going to increase to that is not what I going to increase to 60. And it's going to come along to the 1 minute mark. So that is 60. I know that's on a bit of an angle. That's me, not the actual what's supposed to happen. And then it's going to drop to 40%. That's 40%. And then it's going to go to 51. And then it's going to go to 35. That was 51%. And this is 35. 35%. And then it's going to go to 55. 55%. And this is the process variable with zero feedback. But this is in order to calculate what the integral is going to do. So what we need to do, the integral and proportional. So we calculated out exactly what's going to happen as soon as we turn our controller on. It's going to jump to 45% output because of our proportional gain and our process variable is at 5%, right? Because there's a negative 45 error and we're in reverse acting, it's going to give 45% output. But over time, our integral is going to play a factor. So now we have to calculate out our integral. So at 0.049 seconds, before it crosses over, we're going to go, first we do our proportional, 1 times minus 45 times minus 1, plus 1 proportional gain over our integral 0.5 times minus 45 times our time, which is 0.499 times minus 1. Now, we already know that this portion equals minus 45. Excuse me, I have to sneeze. And then we add our integral. Pardon me? Sorry, that is 45, thank you. Not minus 45, it is 45 plus our integral, which when you 1 divided by 0.5 times 45 times 0.0499 times minus 1 equals 90. Sorry, that equals 45. And you add those together, and that equals 90. Okay? So now our output is going to skyrocket up to 90. Okay? So over time, it went up to 90. Well, now we come and we cross that 0.5 minute mark, our process variable jumps up to 60%. Okay? So now we've gone on the other side of the set point. What that's going to do to us is that's going to change our proportional gain portion. You have to remember that we're going to add all these integrals together. So this whole integral, I'm going to actually color this in with a fancy color. So all this gave us an output of 45 in the integral portion. As we come along, we're going to be adding all these together. And it's going to be going okay, we've got 45, we've got minus, we've got plus, we've got minus, we've got plus, we've got minus, and at the end of it, you add them all together, and that's what will tell you where you're going to be at that time. And we're going to see that. So now, we're going to go, and we're going to calculate what happens after 0.5 seconds. So now, we're going to take our, I said seconds again, 0.5 minutes. 1 times our new error of 10 times minus 1 plus, now this equation right here, that gave us 45, and that was here. We're not going to put that calculation down here and do it again. We already know that's 45. So we're going to, instead, we're going to go 45, because that's the old 45 that was there, and we're going to add it to our new integral, which is 1 over 0.5 times 10 times 0 times minus 1. Because we've crossed that 0.5 seconds and we've increased, now we have to start that timer over again. And because that timer is 0, that's crossed out again. None of that all equals 0. But now we're going to go 1 times 10 times minus 1, which gives us minus 10 plus 45. And that should equal 35. So now we're going to come back and we're going to go to 35. Right up there. So as soon as it crosses over, it drops down instantaneously to 35. The difference from minute mark 0.499 and then it goes to 0.5 and we change our PV up to 60%, our output drops drastically. Because, and that makes sense, our output increased, and so let's say it's our variable frequency drive. Well, now we've gone above our set point. We want to turn our variable frequency drive almost off, right? Because now we're above our set point. When we were below our set point, we turned our variable frequency on. That's what the controller did, and it said, you're not getting back to your set point, so I'm going to keep increasing the speed of your variable frequency drive, causing more water to go in. In reality, we don't have it hooked up, so our process variable did not increase. But it kept trying to increase the input to our system, trying to get that PV to come back to its set point. But then once we jumped up to 60, our output dropped down drastically. Because it said, whoa, you're really getting close there now. So now we want to calculate it at just before it hits the 1 minute mark, before it drops down. Because we want to calculate what our integral is going to do to us now. Okay? That's what we're calculating. So now, again, we're going to do the whole equation, 1 times 10 times minus 1 plus, we're still going to use our 45, because the 45 is that 45 right there that we're carrying through with us. And then we're going to do our equation over again, plus 1 over 0.5, our integral, portion over integral, times, times 10, because our error is 10, times our time of 0.5 minutes, times minus 1, reverse acting. So that's going to give us minus 10 plus 45 plus, and that is going to be, what is that going to be? Minus 10, actually. to come to 25. And this is what happened to our output. Because it was above the set point, integral is still trying to drive it to get back to its set point.
Okay, and we're doing, instead of 0.5, we're doing 0.499 again?
No, this time, yes, sorry. What did I put? I put 0.5, but it was 0.499. In reality, it's 0.5, but it's 0.499999999999999. Okay, so it's 0.5. When you look at this, and I want you to be able to draw it out just like this, because you see that when your process variable is below your set point, your integral is going to drive it up, trying to get your PV up in reverse acting. In direct acting, it would be the opposite. Then when it came above the set point, it tried driving it down to the set point. Well, what do we think is going to happen when we start doing this one? It's going to try driving it back up, right? So for this one, our integral portion was minus 10. Okay? So here we got minus 10. That was plus 45. That was minus 10. So our integral is adding on itself, right? Now some of it's a positive adding and some of it's adding a negative. So at this point right here, our integral, our cumulative integral is 35. It's 45 minus 10, right? We're going to accumulate that integral, whether it's a positive accumulation or whether it's a negative accumulation. And then we just add the proportional component of it, which is proportional times your error. Okay. So now we know we have 35 there. So now we're going to go, now we're just crossing over that 1 minute mark, right? So now we're going to a 40% output or a minus 10 error. So we're going to go proportional gain times our error of minus 10 times minus 1. And we're going to go plus 35. Okay? It was that portion of integral at the beginning was 45, and then the next proportion of integral is minus 10. So that gives us 35. See, there was integral there, there was integral there, 35. Bear with me. You're going to see it. Okay? Plus the 35 plus proportional over integral times our error of minus 10 times our time of 0 times negative 1. 0, cross it out. Now we have, sorry, did we already do that one? Sorry, we're already at 25. And we went to an error of minus 10. Yes. Sometimes you get talking and then you forget where you're at. Where are we at here? Oh, 1. Okay, sorry. We're at 1. So minus 10 plus 35. Oh, that's why. 10 minus 10 times minus 1 is going to give us 10 plus our 35, right? 1 times 10 times minus 1 gives us 10 plus our 35 equals 45. Sorry. So now we're going to jump up to 45. As soon as we cross that line, we jumped up because our error went actually minus 20, so our proportional gain jumped positive 20. So now we have to calculate this integral portion. So now we're at minus 10. So again, we do this again. 1 times minus 10, this is our proportional, times 1, minus 1. We add our integral, which is 35, and we're doing this same equation right here, except our time was 0, and now our time is going to be 0.4999999. But it's easier to rate 0.5 times minus 10 times 0.5 times minus 1. So 1 times minus 10 times minus 1 equals 10 plus 35 plus, we take the 0.5, and that equals 10, which equals 55. Perfect. So now we're going to come back up. At 55, it came up. Okay? Our integral was 10. So here our integral is still accumulating. It was 45, then it was 35. Now it's 45 again. Okay? Now, we're going to calculate what happens to the proportional gain as soon as we cross that minute-and-a-half mark. So, at a minute-and-a-half, we go to an error of what? What was our error? Yes, we have an error of 1. Our PV, our process variable, is 51. Our set point is 50, so we have an error of 1. And so we're going to look at our proportional. 1 times, so our proportional gain times our error times our reverse acting, minus 1. We're going to add our cumulative integral, which is 45, and we're going to add, again, that same equation. Its time is 0, so that's going to equal 0. I'm not going to write out the whole equation again because it equals 0. So we have, that would be negative 1 plus 45 plus 0, which equals 44. Right on. So, as soon our integral was driving us up, and now, because our process variable jumped up by 5, our output is going to drop to 44. Okay? Now we have to calculate, again, the area here. Okay? You see how we're starting to repeat ourselves? It's starting to get very repetitive, but we're starting to work it into our mind. And we're going to see it very clearly when we do it with the controller, and you see that your calculations are going to match the practical side of things. So now, at the minute-and-a-half mark, I'm just going to start again here. At the minute-and-a-half mark, we still have, we just did minute-and-a-half. We're doing minute 1.999 minutes, right? So we still have proportional gain of 1 times our error of 1 times our reverse acting plus reverse acting of minus 1. That's going to give us minus 1 plus 45 plus, and that will be minus 1, which equals 43. So now we're going to come up here and now it's ever so slightly down. This is hard to draw a wee bit here. It only went down 2, okay? Or 2, 1. One went down 1, sorry. So that is a minus 1. And we saw that because this whole portion equals minus 1. The integral portion of this equals minus 1. Now we have to see what happens as soon as this crossed over the 2-minute mark. We're expecting this to jump up. You can see the pattern, right? We see the pattern here. When our process variable is low, our proportional wants to make it jump up. When it goes above the set point, our proportional makes it want to jump down. Over time, the integral with our process variable being low, over time our integral wants to drive our output up. When our process variable is above our set point, over time our integral wants to drive it down. Okay, so at the 2-minute mark, what happens when it passes the 2-minute mark? Our process variable dropped down. We're expecting our output to jump up. So our error, 35% proportional process variable of 35%, gives us an error. And I keep saying this because in the lab, you're going to notice that sometimes I give you the error, and other times I give you the process variable. And when you know the process variable, you know the error, but you have to calculate the error by saying it is below the set point by 15, which means I have a negative 15 error. So we go proportional gain, which is 1, times our error of minus 15, times minus 1, or reverse acting, plus, now we're taking these two, which is our cumulative integral to this point, which is 44, plus our new integral, but it's a time of 0, which gives everything 0. So 1 times minus 15 times minus 1, that's going to be 15 plus 44, which equals 59. Is that what I got? Yes, it is. Minus 15, minus 1, plus 15. So that was 59% output. So now we're going up to 59% output. It jumped up just as we expected. Now we have to calculate out all this integral that's going to happen from that area of error over time. I'm expecting it to increase over time because it has had a negative error over time, and because this is reverse acting and it's integral over time, it's wanting this to get back to its set point. So we are going to do 1 proportional times minus 15 times minus 1. This is all the same. This is the same. Plus 44. Plus, the only thing that's changed is our time over here changed. So we have to now do a new calculation. Proportional over integral times your error of minus 15 times your time of 0.5 times negative 1, which is your reverse acting. So that gives you 15 plus 44 plus 15 equals 74. Right on. We're doing awesome. So it's going to jump up to, let's see if I can make this kind of look half decent here. It's going to jump up to 74. Now, now that also gave us an area of 15 right there. Okay, that gives us an integral number. See, these numbers keep adding to each other in the equation, right? So now, as soon as we cross the 2.5 minute mark, we see that our process variable passed the set point, so I'm expecting a drop. Okay? So we're going to come back down here. It jumped up to, did it jump up to? 2.5 minute mark. It jumped up to 55, which gave us an error of plus 5. So our process gain is 1 times our new error of 5 times minus 1 for reverse acting plus our 44 and 15, which is going to be 59, plus this same equation, but our time is now 0, so it's going to be 0, which equals minus 5 plus 59, which is 54. Perfect. Okay, so now I drop down to 54% output. Now, over time, what's going to happen to my output? Our output is going to drop, trying to get us back to our set point. Now, keep in mind, this one is different because I went from 2.5 to 4.5 minutes. The last one, I'm spreading out over 2 minutes. So I'm changing my time. It's no longer going to be a time. The time from here to here was half a minute. From there to there was half a minute. From there to there was half a minute, and from there to there was half a minute, and there was half a minute. But from here to here is 2 minutes. I know I didn't I should have, actually, let's do that. Let's extend that out. 4. There we go. That's a little easier to digest. Sometimes I forget that this thing scrolls. So we're looking to see where our output is going to be way over there. So now we have to go 1. That's our proportional gain, times our error of 5, times reverse acting, plus 59, which is our cumulative integral at this point, plus our new integral that happened, which is 1 over 0.5 times our error of 5 times our time of 2 minutes times our reverse acting. So this is going to be minus 5 plus 59 plus, that's going to be 10, 5 minus 5. Is that right? Why does that not feel right? Oh, sorry, that is, that's supposed to be 20. So, that is minus 20. I didn't do that calculation right in my head at all. Minus 20. Which equals 34. Right? Yes, it does. Okay, that is correct. So we have an output. So this integral equals minus 20 And that takes us down to 34% output. So we see, and this is what I want everybody to do, is to do the calculations just like this. Not try to shortcut and only do this point, that point, that point, that point. Do it out correctly. Because this way you see how the proportional is going to react, then how the integral is going to react over time. And then next week we'll be getting into derivatives and how it's going to anticipate what is happening and what's going to happen. Okay? So this is the practical side of the integral that we want to look at. Keeping in mind that this is reverse acting. But if it was direct acting, the output would happen the same, but just in reverse manner. Okay? So, that's our lecture. Does anybody have any questions about that?
Can you go back
Yeah.
to the